Okay, hello, hi. Kindly check if I'm audible so that we can start. Just let me know if I'm audible. Audible enough? Okay, hi, good morning. Okay, so we are going to have revision session today of work and energy. Yes. Okay, thank you, Sudarshan. Understood. So what we are going to do today is we are going to have a revision session on work and energy. The lesson has already been taught. The link is already available on our channel. So you can view that period anytime as you want. But today what we'll be having is, as you are having exam just in the upcoming week, we will just revise the lesson. I wanted to go through the topics, like the point wise, definition wise to teach you again. But that would be a waste of time, I think, right? Teaching you those topics again and again, it doesn't matter. So revision, what we'll do is, we will take questions. We will revise the lesson with the help of questions. So is it fine? So that you will also be able to interact. It will be a two-way interaction. You will also be able to give the answers, and that will be the a proper revision, we can say. Correct? Okay, right. So in that way, we will proceed. Is it fine? Okay, super fine, super fine. Sure. Can we start now our session? Okay. So I'm putting some questions in front of you. All you have to do is give me answers for it. Right? We'll be discussing answers for questions. Okay. So let's start. So the first is this one. The first question that is in front of you is this one. What are the units for work and energy? A very simple question, a very super duper simple question. What are the units for work and energy? With the help of questions, we'll be revising it. Okay. So the answer is yes, very much correct. The answer is going to be yes. The unit of work is joule, and the unit for energy is also joule. Yes, joule and joule. Both of them have the same units, SI unit. These are the SI units. Both have the same units. Work has also the same unit. Energy has also the same unit, that is joule, and that is SI unit. And what about the CGS units? CGS units are, both of them are having that is erg and erg. Correct? Okay, so that is the differentiation point of work and energy. Okay. Joule for SI unit, and yes, correct. And erg for CGS unit. Now, can somebody give me answer for this? Can somebody give me answer for this? Sure. You just have to give me answer for this. A very simple question. Sure. How much work is done when a body of mass m is raised to a height of h above the ground? Okay, a very simple question. How much work is done when a body of mass m is raised to a height above the ground? What do you think? What will be the answer for this question? How much, suppose let's say, work is done if a body is raised to a height of, yes, above the ground, above the ground. Okay, correct. That is mgh. Obviously, that is true. That is so true, because formula for work done is force into displacement. Force into displacement. But in our case, the force can be given by mass into acceleration into s. But in our case, displacement is height. Displacement is height, right? Which is h. S is equal to h. So we have to put s as h. And we also know acceleration due to gravity in our case is g. So that will become m into g into h. So that is our answer. Work done when a body is raised to a height h is nothing but mgh. Yeah, correct. Very much correct. Chalo, a new question in front of you, a very new question. Is work a scalar quantity or a vector quantity? What do you think? Work is a scalar quantity or a vector quantity? The answer is it's a scalar quantity. Always remember it's a scalar quantity. It's a scalar quantity. Always remember that. Problem is what happens is the formula for work done is force into displacement. So many people think that as this is vector, many people think that as force is vector, then suppose displacement is vector. So people think that this is also vector. Okay, but this logic is wrong. This logic is totally wrong. That it's not a vector. The logic is wrong. The answer is it's a scalar quantity. Why? What is the reason? See, you might be having, suppose, let's say these kinds of rules you must have learned in your lower grades indices. Like for example, a raised to m into a raised to n is equal to a raised to mn, right? Basically, like addition, we can add those numbers, correct? Okay, so those kinds of indices rules, or even for example, like rules like these. Suppose there is a number here that is square, and suppose let's say 3. So you can just multiply both of them, that is AB, correct? A and B, so you can multiply, suppose, suppose let's say C and D, for example. So that means A raised to C into D. That kind of logic. So you have various rules which you have remembered, Pythagoras theorems, identities and all. In the same way, in 11th standard, you will be taught something called as multiplication of scalar quantities and vector quantities. You will be taught multiplication of scalar quantities and vector quantities. Like what happens when you multiply scalar with scalar, scalar with scalar, or you multiply scalar with vector and vector with vector. So these are certain rules which you need to remember. That these are rules, the proof that will be taught to you in your 11th grade. So we are not going to discuss it right now. But always remember, whenever you multiply vector quantity with vector quantity, whenever you multiply vector with vector, all you get is scalar, a scalar quantity. So this is basically one of the rules that will be taught to you in your 11th standard. But right now you just remember it, that what it is called as, it is nothing but scalar quantity. Understood? So when two vector quantities multiply, they create a scalar quantity. Always remember that. So your work is scalar. Your work is scalar. Now, as we have decided work is scalar, what about energy? If work is scalar, what about energy? Similar, energy will also be scalar quantity, as both are having the same units. Correct? Are you understanding this? A very important question. I wanted to discuss this one, and we have done that. Correct. Okay. Fine. Now, can we discuss something more? Can we discuss something more? For suppose there is a one condition which I want you to know. They will be asking a higher grade formula. So I had told you that, for example, the actual formula which is given in your book is work is equal to force into displacement, right? So let's say we have talked about this. But the main formula what we have in syllabus, for example, like actual formula which is going to be there in higher grades, or even suppose let's say in 9th standard in competitive exams, the actual formula is work is equal to Fs cos theta. Fs cos theta. I will just give you a brief idea about this so that you can understand what is the logic. Okay? Because you should know this. You should really know this, what exactly it is. So what happens is that suppose a person is, suppose let's say this is your V. Okay, this is your small toy. Suppose let's say this is the toy, and see this is you. This is you who is, suppose let's say dragging that toy with a thread. So this is the thread in your hand. Okay, this is the one, and suppose you are walking on this particular ground and you are applying force in this direction. the applied force is in this direction. तुमको नहीं लगता? So let's say the applied force is in this direction, like it is inclined, but the displacement, the toy is moving in this direction. The displacement is happening in this direction. Correct? So that means there is a certain angle. This is displacement we are talking about. This is displacement, and force is being applied in some direction. Displacement is happening in some other directions, right? And the angle between them we have to use for calculation, and that is theta. The angle between them, that is force and displacement, we have to use in our calculation, and the formula is W is equal to Fs cos theta. Cos theta means it's the function of cos, that means cos 90 or something like this. So let us just see what are the values of cos in terms of different angles. So if you are talking about cos 0, okay, what is the value of cos 0? You should just know some basic numbers. Cos 0, then you should know cos 30, then you should know cos 45, then you should know cos 60, and then cos 90. Fine. Okay, so these are the degrees which you should know, should remember. So the numbers are 0, then suppose let's say 1 by 2, then 1 by root 2, root 3 by 2, and 1. Okay, these are your numbers. So you don't need to remember the complete table, but you just need to remember this value. You just need to remember this value for your 9th grade, that is school exams. These are for the complete competitive exams. But you can just remember the last one, that is for school exams. You should know this, that whenever there is an angle of 90 degree between force and displacement, then the work done, the value of cos is 0. Are you understanding this? That whenever the angle is 90 degree, the angle between force and displacement, what is going to happen is your cos theta value will become 0. And you just tell me, if I take theta is equal to 90 degree, theta is equal to 90 degree, what is the formula? Force is equal to, work done is equal to force into displacement, right? Work is equal to Fs cos theta, but what is the value of theta? 90 degree. So F into S into cos 90. Now according to our information, what is the value of cos 90? That is 0. So F into S into 0. So everything will become 0. So can I just say work done will become 0 if the angle between force and displacement is 90 degree, that is they are perpendicular to each other. Okay? They are perpendicular to each other, then we can just say that is 0. Are you understanding this? Okay. So rest of the numbers we are not going to talk about, because all we need is just 90 degree. For our calculation purposes, we just need 90 degree. For school level, that is more than enough. Because then I have to talk whole thing about trigonometry and all, that will just complicate the subject. So can you please tell me, like in which two cases, suppose let's say the work done will be 0. The work done will be 0, you just have to tell me. If the displacement is 0, can I say if the displacement is 0, work done will be 0? Displacement is a 0. The object is not moving even after applying force. Displacement is 0. What about the second case? Second case is that if the angle, in the exam if they ask you that when the work done will be 0, so if the displacement is 0, then work done is 0. Angle between force and displacement is 90 degree, then also work done is 0. Angle between force and displacement, if it is 90 degree, then also work done is 0. Is it fine? Okay, so work done is 0. In this case also work done is 0. Okay, these are the only two things I want you to remember, nothing more. Work done is 0 if displacement is 0, and if the angle between them is 90 degree. Correct? Okay, can we move on to the next one? I hope this kind of revision is helping you out. Okay, fine. Now, we will apply some logic of friction now. Let us have this question. The question is, what is the work done against gravity when a body is moved horizontally along a frictionless surface? What happens? What happens? What is the work done against the gravity when the body is moved horizontally along a frictionless surface? What do you think? What will be the work done by the gravity when the body is moving horizontally along a frictionless surface? So that means Suppose let us say this is our surface and some car is moving over it. There is one car and it is moving over it like in this direction. They are asking what is the work done by the force of gravity. Yes, correct, correct, correct. Work done in this case will be zero. Work done in this case will be zero. The reason being, see, there are two forces which are acting. This is what I can say is horizontal force. This is horizontal force, like which is applying like on horizontal direction. Okay. And the gravitational force is below. The gravitational force is this. This is F gravitational force. Okay. Right now the object is touching the ground, so the object is not moving under the influence of gravity. So right now the gravitational force is zero. This might have a number, let us just say it might have 40 Newton forces being applied, because of that it is moving. But if you are talking about gravitational force, in this case it is zero, because the object is already touching the ground, no gravitational force is being acting it on right now. So nothing to do with that, suppose let's say surface. So gravitational force is zero. So if I am talking about work done by gravitational force, by gravity, the formula would be F gravity into displacement gravity, right? Displacement due to gravity. But we have seen our force is zero, correct? In this case, the motion which is being, let's say, which is available in our car, there is no motion due to gravity right now. So gravitational force, even though it is acting on the body, but it is not causing the motion. It is not causing any motion, no motion due to gravity. Are you understanding this? It has its own force due to which it has motion, but it has nothing to do with the gravity. Okay, so what we are going to do, what we are going to say, a simple logic what we are going to say with this is that our gravitational force is zero, and because of that even our displacement, it doesn't matter what it is, the answer is going to be zero. Correct? Gravitational force is zero, so work done by gravity is also zero in this case. Are you understanding this? Okay. Just tell me in short if you are understanding this. Okay, understanding the logic. Just let me know if you are understanding why our gravitational force is zero. Just tell me that. That will be easy. Okay, fine, fine. Okay. Now moving on to the next question. Yes, I will also give you a formula sheet, but kindly wait. Yes. Now a very simple question is being asked to you. Just think over it and just give me the answer for this. A very common question which is asked. This one. In the numerical one, this question is asked very commonly. I will give you a list of the formulas also. Let me just complete this question. Then we will create a list of the formulas. Fine? Okay. You just have to apply the logic and you have to tell me what will happen to the kinetic energy if the speed is doubled. So if the speed is doubled, what happens? What happens exactly to the kinetic energy? That is what is being asked. Okay, a very simple one. A very simple one. Okay, 4 times. 4 times. Yes, correct. Exactly. Let us see how it can be solved. So what they are saying is, if the speed is doubled, what is going to happen? So let us just say the initial speed is v1. Let us just say the initial speed is v. The mass is m. The initial speed is v. Okay. The mass is m. Okay. Now kinetic energy for the first case. Kinetic energy, suppose KE1. If we say it is KE1, the kinetic energy for the first case would be half mv square. Correct? Half mv square for the first case. What about case 2? Case 2, in which we are doubling the speed. The speed has become double now. That means 2 times v. Correct? The speed has doubled now, so I have increased the speed from V to 2V. Okay. What about kinetic energy? If you are writing down about kinetic energy, it will become half m. Mass is same, mass has not changed at all, but the speed has increased from V to 2V. So I have to keep 2V in the bracket and it's a square, right? Velocity, in place of velocity I have kept 2V because speed has increased 2 times. Now we just square it. So 1 by 2m, what is the square of 2? That is 4, and V square is V square, right? So that is 4V square. So you can just divide it. So that will be, take that 4 to the front side. So you can take 4 to the front side, and what is remaining is half mv square. But as you can see, half mv square is equals to kinetic energy, right? So this complete part is nothing but the first kinetic energy. To replace that, as you can see, the complete that half mv square is nothing but kinetic energy 1. So you can write it in that way, that this is equals to 4 times the initial kinetic energy, which is kinetic energy 1. So kinetic energy 2 is equals to 4 times the kinetic energy. So it has not just doubled, it has the kinetic energy has increased 4 times. The kinetic energy has increased 4 times. Right? Okay, a very, very basic question which is asked like many of the times in the exam. Okay, correct? Fine. Okay, so will you be able to do even for half positions? What happens for the half positions? Okay, just tell me in the comment section whether you will be able to do it for half things also. Like if the velocities are half or something like that, will you be able to do? Okay. So kindly solve this question now. You have to solve this question of how fast should a man of 50 kg run so that the kinetic energy will be 625. So it's a very simple question. They have given kinetic energy. Kinetic energy being given is 625 joules. Mass is already given. Mass they are saying it is 50 kg. All they are asking is how fast. That means velocity. Basically, they are asking. What is v? Can you please find out v from this? Just use the formula and kindly find out the v value of v. That is half mv square. Okay. Let me know. Let me know about this. Okay. Mm, 25, 5. Okay. So you just have to put the values there, nothing more. Put the value 625 there. Okay. Then put half. Then you can suppose let's say put the value of m also, that is 50, and then v square. Shift all the numbers to the other side. It will become 625 into 2 divided by 50 is equal to v square. Okay. Now you can start dividing the numbers. So that is basically 2 ones are 2 25s are 25 ones are 25, 25 is 625. So it has become 25 is equal to v square. Take square root on both the sides. So it will become 5 plus minus 5, but you can ignore the rest of the things. So you can just say it is 5. Velocity is 5 meter per second. Okay? Very simple. Correct? Okay, that's true. That's true. Okay. Now I am giving you somewhat a difficult numerical, somewhat complicated. Nothing too much fancy, but just a comparison, so that you'll be able to do it properly. Okay. So the question is, two bodies A and B of equal masses are kept at heights h and 2h respectively. What will be the ratios of their potential energies? So they have given two bodies, they have equal masses, and they are kept at heights h and 2h. They are asking for the ratios of their potential energy. Okay, can we start solving it? Okay, a very simple one. I will give you the general idea and then you can do it, right? Okay. So on one side, I will be writing data of body A. I'll be writing data of body A here. And on other side, I'll be writing down data of body B. This is the way you should solve in the exam so that there will be less confusion. Now, what is the mass? The mass has been told as M. For A also the mass is M. Let us just assume the mass is M. And the mass for body B is also M. Both masses are same. What about height? Height for A is h, and the height for suppose let's say B is 2h. Correct? The heights are different. The heights are different. What about potential energy? Potential energy. Can you find out the formula? What is the formula for potential energy? It is mgh. Formula for potential energy is what? Mgh, right? Okay. So we have already replaced the values here. Now, what about potential energy in body B? Let us just say this is potential energy A and we are finding out potential energy B now. The value is you have to multiply mass into acceleration due to gravity into height. But in this case, the formula is m into g into what is the height in this case? That is 2h. The height in this case is 2h. So the formula in this case will become 2mgh, right? That is potential energy B. Now they are asking to take the ratios of them. They are asking to take the ratios of them. That is potential energy A divided by potential energy B is equals to, you can just write down the formula which you have derived. First put mgh. Okay. Then you can put 2 mgh. Cancel them out. So what will become? The answer will be 1 by 2. So simple. Potential energy A divided by potential energy B, that's it. 1:2 ratio. Fine. The ratio is 1:2. So all you have to do is use the formula, basic formula, put the values and just take the ratios. So simple. Okay, I hope you are able to understand this. Okay. Now, can we have something, suppose let's say more regarding such kind of numericals? Okay. Giving you something very special, a very simple one. Just a very simple calculation in terms of our numericals. The question is, we have been given the mass. The mass is 100 kg. A load of 100 kg is pulled by up by 5 meters. So 5 meter must be displacement. This is displacement and this is mass. So displacement is 5 meters. Value of g is also given, that is 9.8. Okay, meter per second square. And they're asking us to find the work done. That is what is the value of W. They're asking us to calculate the value of W, that's it. Okay, the formula is work is equal to force into displacement. Okay, but force is mass into acceleration. Acceleration we can write down in the form of G, right? Acceleration we can write down in the form of G. And displacement, that's it. Put the values and find me the answer. 100 into 9.8 into S, that is 5. Just multiply the numbers and get me the answer. The answer would be, this is 98. 10 will be cancelled with the decimal and this will become 980. Correct? This will become 980 into 5. Just multiply them. What will be the answer? 500. 5 is a 40. 4 carry. 5 is a 45. 45 plus 4. 46, 47, 48, 49. Yes, 4900. So the answer is coming as 4900. And the unit would be joules. Are you understanding this? How to calculate 4900 joules? Okay. Fine. Okay. I think it's helping out. Correct. Okay. Now, can I give you something somewhat difficult? Somewhat difficult can I give? Not that much, but at least somewhat. Okay. So here is the question. I will also explain it, but finally you have to answer it. Fine. The question is something like this: a car is accelerated on a level road. There is a car which is in acceleration, and it acquires a velocity 4 times the initial velocity. So the now velocity has become 4 times the initial ones. Initially it was something, now it has become 4 times. So let us just say initial velocity is v. So the new velocity has become 4 times. During this process, the potential energy of the car, what will happen to the potential energy? If the speed is increasing, suppose let us say, yes, if the speed is increasing by 4 times, what is going to happen with the potential energy? Out of the 4 options, you have to give me the correct one. Out of the 4 options, you have to give me the correct one. Yes, obviously, the correct answer is does not change. Does not change. Always remember, the potential energy is calculated with the formula of mgh, which doesn't have any velocity, no velocity. It doesn't have any velocity. Yes. So even if the speed increases, there is no change in the potential energy. Are you understanding this? No change in potential energy. No change in potential energy. Always remember this. Even if it is the velocity changing, it has nothing to do with the suppose let's say potential energy, because the formula is mgh. It doesn't have velocity, so no change in potential energy. But you might think, but sir, velocity has changed now. Some kind of energy must have changed. Yes, obviously, velocity has changed. Only potential energy has not changed. But another energy might have changed. Which energy has changed? Kinetic energy. Kinetic energy has changed. Obviously, kinetic energy has changed. And that too, how much? 16 times. 16. Because the formula is half mv square. So that there will be squaring of this 4 number, right? So that means kinetic energy has changed. And that too, how many times? 16 times. 16 times the original. Kinetic energy has definitely changed, but there is no change in potential energy. Okay. Okay. Now a simple question is being asked, a theoretical one, work done. Okay, let us have that. A very simple theoretical kind of question. Kindly, this is a multiple choice question, so kindly think over it and give me the answer. The question is, the work done of an object does not depend on the work done on an object does not depend on the exactly depends does not depend on what? The work done on an object does not depend on what? Can you please tell me? Out of these 4 options, which can be the correct one? Yes, Rushikesh correct. Yes, Urjit correct. Yash correct. Yes, Karthik correct. Jayesh correct. Yes, the answer is initial velocity of the object. Because the formula for work done is, we have seen there are 2 formulas, that is Fs cos theta. The formula is Fs cos theta. So that means work depends on what? Force. Obviously, it depends on force. Work also depends on displacement. Work also depends on the angle between, suppose let us say force and displacement, angle between these two. These two have, suppose let's say whatever is the angle on it also it depends, but it has no relation with the velocity of the object. Work done doesn't depend on the velocity of the object, it has nothing to do with it. So the answer is going to be D. It's just according to the formula, nothing more. Just based on our formula, that's it. Okay. Now, can we do one thing? Can we suppose let us say just have a formula sheet over this? Let us just create a formula sheet for this. That will be helpful, I think. Yes. By the way, what is the date of the paper? For suppose, let us say, for science paper, I think it's the last one, right? This time, something like 2021. What is the date? Hmm. Just the date. Just the date. Okay. 21. Okay, ठीक है. So what we'll do is we'll make a list of the this thing formulas first, so that you can revise from that. ठीक है? Formula sheet. Formula sheet for this lesson. Okay, so let us start. The first formula you are supposed to remember is of work. Okay, the first formula sheet we are trying to make. The first formula you are supposed to remember is work is equals to force into displacement. Work is equals to force into displacement. So the formula becomes F is equals to Fs cos theta. Fs, that is force into displacement, that is the first formula you can remember, and its advanced version is something like this. F is equal to sorry, it's W, sorry. Okay, so work is equal to force into displacement, and the advanced version of that is work is equals to Fs cos theta. That is the angle between the two, where theta is the angle between force and displacement. Okay, so that is the secondary formula you should remember. Okay, that is the first one. Now let us go with the second formula. That is the first one, work done is equal to force into displacement, or you can remember it is Fs cos theta. Fine. Okay. Now the other basic things you already know. What is the formula for force? That is force is equal to mass into acceleration. Force is equal to mass into acceleration, or force is equal to mass into acceleration due to gravity. The other two formulas you already know. Those are from your previous lesson. So I don't think there is any issue regards to that. Correct? Okay. Now let us talk about kinetic energy. What is the formula for kinetic energy? Kinetic energy formula is half mv square. Kinetic energy is equals to half mv square. Kinetic energy. But we represent that with letter Ek, right? Kinetic energy. So kinetic energy, that is Ek, is equal to half mv square. Kinetic energy. You can write down in bracket this is kinetic energy, so that there won't be any confusion afterwards. Right. In the same way, we have another formula, that is potential energy, that is EP. Potential energy, that is EP, is equals to mgh. This is potential energy. Okay, kindly remember this as well. Potential energy. Okay. Now, sometimes they might ask you initial potential energy. So, let's say a change in potential energy, and sometimes they might ask you change in kinetic energy. So, that is actually very simple. Suppose, let us say they ask you change in kinetic energy. That means initial kinetic energy and there is a change in velocity or mass, something like that. And they're just asking what is the change in kinetic energy. Okay, so the change in kinetic energy can be calculated by kinetic energy, which is final minus initial. So that's a very simple one. Kinetic energy final minus kinetic energy, which is initial. You just subtract them. Change in kinetic energy, it means what? Basically, you have to subtract kinetic energy, which is final, minus kinetic energy, which is like initial. Fine. Okay. Same thing happens with potential energy also. Same thing happens with potential energy also. Change in potential energy is equals to. Can somebody tell me the formula for this? Apply the logic and tell me the formula for change in potential energy. It would be EP EP final, that is energy, potential energy final minus potential energy which is initial. Exactly. Okay. Done? Yes, done and done. Okay, correct. And just a last formula, that is mechanical energy is equals to. Sometimes they might ask you that body is also having potential energy and the body also has kinetic energy. They might be giving you certain example that the body has both the energies. Then you need to do one thing. They will be asking you to calculate mechanical energy. They will ask you to calculate mechanical energy. So mechanical energy is equals to, let me just say I am representing this by EM. ठीक है, mechanical energy is equals to kinetic energy plus potential energy. Are you understanding this? A very simple one. Mechanical energy is equals to kinetic energy plus potential energy. So can I modify this formula for, I can put the values of kinetic energy. The formula for kinetic energy is half mv square and the formula for potential energy is mgh. Very simple. Okay, so that is my complete formula, mgh. Fine. I think this will work. Okay. Now after this, there is one more formula, that is for power. Formula for power. Yes. Power is nothing but work divided by time. Formula for power is work divided by time. Yes. So that means P is equal to W by T. You can also replace here, that is work is nothing but force into displacement by time, and it can also be represented as F is nothing but m into A into S divided by T, or it can also be represented as mgh by T. That is up to you how you are representing this. Are you understanding this? And this is also equals to energy by time. As work and energy are same, so you can write down the formula as P is equal to either W by T, or either you can write down P is equal to E by T. That is up to you. ठीक है? According to the question, you have to use these formulas. According to your need, you have to use. It looks complicated, but it is not. It is just we are expanding it, nothing more. So simple actually. Correct? It's actually very simple. It is just we are just extending the formulas, nothing more. Okay. And just a conversion you will require in the exam, a simple conversion. So kindly please remember that as well. The conversion is, yes, the conversion factor between kilowatt and joule. Conversion factor, please remember that it might be necessary for your calculations. Okay, so the conversion factor is 1 kilowatt hour is equals to 3.6 into 10 to the power 6 joules. Okay, this is the conversion factor I want you to remember. 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. Okay, so that is another important point you should remember, but that's it. This will complete your whole formula list for your lesson. Fine. Okay. So I have given you the complete formula list and everything, correct? Okay. So what we'll do is kindly revise the lesson as per your need, and suppose let's say in a week or so, if you are having suppose let's say doubts, complete the lessons. Our videos are already available on our channel, so you can see those as well whenever it is required. But even after that, I can understand that as these are online classes, you might be suppose let's say having certain doubts. So whenever the next session will be conducted, that will be a doubt session. Whatever the doubts you have regarding suppose let us say all the lessons, you get them cleared in the next session whenever it will be conducted. You kindly get solved your doubts, whatever those are related to any of the lessons like motion, laws of motion, work and energy, whatever the doubts you have, kindly ask them, get it solved. But by that time, please study all these lessons. Correct? So we are ending our session for the day, and I will keep you updated for any of the changes or any of the new information or classes if you are going to take. So thank you so much for today, and we'll be meeting in the upcoming session. Sure. Thank you. Bye-bye. For maths, I will let you know topics for maths which are really important in terms of preparation for class 10. I will let you know later in the upcoming session, not today. We'll close the session for the day. Okay. In the upcoming session, I will tell you about maths also. What to study from the maths for class 10. No issue. Okay then.